Hello. Oh, I'm a bit of a shadow there. There we go. It is sunny outside. Thank you very much for joining me on this glorious Saturday morning, or whenever you're decided to watch this. Thank you very much for joining. My name is John Stevenson, and welcome to Practicalli. So this week we're going to continue our kind of longish journey into building web apps backed with a database. So it's very much step-by-step guide of my experiences doing this. And this week I've experienced some challenges between like the Clojure world and the database world. So we're going to cover some of those and specifically try and do some testing using spec to generate data and be able to populate our databases from that spec generated data. There's still plenty of work to do, so there is lots of homework to do if you want to do it, but I'll be continuing working on this next week as well, and so hope you enjoy. So before we start, just a reminder, the website practicalli.github.io or practical.li. Still sponsored by Clojure Together, so thank you very much for that. That's helping me spend a lot more time on these. And as usual, all the broadcasts are on the web. These particular broadcasts are grouped under the Clojure server-side web apps and APIs. So there's lots of videos specifically around that topic. And we've got over 80 videos in the Clojure study group altogether. Plenty of stuff to do. If you're just learning, then I do recommend looking at the 4 Clojure guides as well. It helps you understand a lot of the functions that are in the core of the Clojure library. And all the books. I'm continuing working, mainly doing a lot more on the Clojure web apps content. So we'll see some of that today as well. And if you want to get in touch, then Clojure Slack community, there's a Practicalli channel. And there's also lots of other channels there to help you do lots of to ask questions about specific aspects of development with Clojure. And thank you to everybody who's already sponsored me and subscribed to the YouTube channel. There's over 700 people on there now. Woohoo! Thank you very much. That keeps me going. Yes, any kind of feedback is welcome about what you want to see. Okay, where we go. So we've been working through this banking on Clojure in the Clojure web apps book. So I'm continuing to add content here, and so we've already done the database queries. We've got the application running and instrumented a whole bunch of things. So one of the interesting things, and just an aside. One of the things I came across this week was cyclic load dependencies. I think I've got an error message here. There we go. I got an error message like this, and it did take a little while to actually fix this, and it was a rather easy fix, and actually a good prompt to get me to step back for a second and just reconsider what I was actually testing, because it turned out I had a specification I was instrumenting that actually I wanted to kind of move to a different namespace anyway. And so what I'd done was I got this error. So when I shut down the REPL and started reevaluating the code, part of that evaluation is to evaluate the namespace definition. And so I've got several namespace definitions. Obviously, you've got one for each file in the project. So in the files we've got, in the source Practicalli request handler .clj file, we've got the Practicalli request handler namespace, and that's got to require. And that's including so request handler is including obviously the hiccup stuff we're using, although eventually I'd like to refactor that out into kind of its own UI namespace. we'll need to keep ring util response because we're using a response to return ring style responses to back to the web application server to return the pages that we want. But and then we're including this Practicalli database access. So this is our functions to be able to access the database. And yeah, I think where we got the, no, it's not what I wanted. There we, oh yeah, namespace design. So let's just revisit this for a second. Yeah, so we've got the system itself, which does at the moment it's doing the routing, and then we're passing off to handlers and middleware. There's still the UI stuff in the handlers and middleware to separate out, but then these handlers are calling data queries and data sources. Again, this at the moment, these two namespaces are just the same one at the moment, just data access. And what I'd got was I got a specification namespace as well, which is not shown here. And I'd got handlers requiring data queries, which is okay. So the data access namespace. But then that required the specifications, and then in the specifications I required the handlers. So it's kind of going around in three, between the three different namespaces. So therefore I got this cyclically loaded error. So it's going from Practicalli database access to request handler to specification banking to database access. So it's going around in a circle. It is a warning. I mean, the REPL is still running, but it's something that obviously highlights the fact that you probably should do some refactoring, or you've included something that you didn't actually really need to. And that was the case with me. I got the database access in request handler, which is fine. That's what I wanted to do. And then in the database access, I got specifications, which is okay because I wanted to test the database access with some specifications. So I did include that initially. And now I've actually moved that to the actual test namespace for database access. So there's a database access test namespace where we can actually do the specifications, and then I can also include the generative testing in the unit testing. So that removing that into a test namespace also breaks the cyclic dependencies quite nicely. And also with Practicalli specifications banking, I'd actually put some instrumentation. So I've been instrumenting kind of like the request account holder in the which is in the request handler namespace. And so because initially I was going to run the spec against that, but then thinking about that, actually I'm passing in to the handler, to the register, I'm passing in a request. I don't really want to I shouldn't really need to put a specification around the request. It's pretty standard. It's generated by ring, and it's only kind of part of the request that I'm wanting to do. So it's actually when I've extracted the customer data, the customer details from the spec, from the request, then that's the kind of level of abstraction I want to be able to test with the specification. So actually removing this and putting that into the kind of database access is more important, is a more appropriate kind of area where I want to test with the specifications, where I want to do the generative testing. And so just removing either that one or that one actually just breaks the cyclic dependencies. So you can still kind of work with this. I was working for quite a while in the REPL before I noticed this. So it is quite useful on occasion to shut down the REPL and start again. So typically I'm kind of using the REPL kind of constantly. I just suspend my computer and the REPL still kind of running when I might unsuspend the laptop. But at some point, it is useful to check that things are working correctly. And one way to do this is obviously run run a unit testing framework on the command line, because that's going to compile everything from scratch. And that way you can kind of make sure that you haven't got any of these kind of little issues. Where is it? Oops. Do I have that? No. There we go. Yeah, so I'm running. So I've been running. Oops. Clojure, and it's just generating, and it's also running the specifications. So I've got a plugin that runs the spec test check. So it'll also run the instrumentation. So running this, I can't remember if it was, I think it was when I actually pushed the code to Cyclical CLI, the continuous integration server. Then like running Clojure locally as well is also another way to make sure that your application is working and you don't have any bugs. And oh yeah, I've got some. We'll come to that in a moment. That's another error that I came across. But this is a good way to check that you haven't got kind of these little cyclic load dependency issues, because you would get that showing up in the when you did a test run. In fact, if I go to Cyclical CLI, then you can see, if we go to the app, you can see I've got quite a few failures, unfortunately. Whoopsie. So I think, yes, it's not been a good week for Cyclical CLI passing. So I think in here, there's some cyclic dependencies that it came across as I was building things. So it's just in the report. I'm not quite sure which one. But yes, so it's so you'll get a warning here about these kind of things. So it's quite easy to, if you keep an eye on your builds, then you can see that these kind of issues arise. Okay, so that's an interesting aside. So we'll get back on to spec generative testing, because I've fixed that. There we go. But then I found lots of other interesting issues as well. So where we finished off last week, we'd done the database queries, and we got to where we created a whole bunch of queries to do basically like the CRUD, create, read, update, insert records. And these are kind of just wrappers around the kind of JDBC execute initially. So I was using that for creating tables, but for creating records, then I'm wrapping the friendlier next JDBC function of JDBC SQL insert. There we go. And so we've got these create records, which just basically take a database spec, the table name, and some record data, and then they basically just do an insert using the record data, which is a Clojure data structure. And that's when we go and kind of look at the data structures we're actually using, it's just a map. Because we like maps in Clojure, they give a lot of context to the data that we're working with. And so I was just using a very hard-coded approach to just generating the UUID. And I could basically do a create record, so do an insert with the dev database on this particular table name. And so we're passing in the table name as a Clojure key. So we've got this colon, which is the name of the database in the database table that we've created. So this kind of maps up to the banking on Clojure public tables. So we've got a public dot account holders database, and that's what we're passing in there as well. Boom. So this is mostly the same, although you'll notice there's a slight difference that we'll come into, that these are using snake case rather than kebabcase that Clojure normally uses. So we have seen in previous videos where we can actually generate Clojure data, Clojure values from the specifications that we've created. And we've got a whole bunch of specifications in the kind of Clojure specs section that we've already defined. But if we use the Clojure spec alpha gen function, we can give that a particular specification, say account holder, and that will return a kind of reference to a generator function that will generate specific data based on the account holder specification. And then we can use generate to return a single value that is representative of the spec, that actually conforms to the spec. So if we've got a string, it'll return anything that kind of fits inside a Clojure type string. And if we've got a spec that expects a map with certain keys, then we'll generate a map with the keys and the relevant values in that as well. There's also a sample that we used in the past, which will generate like a sample size of 10 values for that particular spec. So we can generate this spec. We do specgenerate for this particular specification generator. Then it'll return a value for us. And in the code, I've added this mock data account holder, mock data for the account holder, and it's simply doing a specgen generate account holder. And then we can call this wherever we need to, without having to include all the spec namespaces in other namespaces. So we just need to include wherever we define this and call that function. Let's jump to the code. Where did I put that? Oops. Jump to the code. So if we go, oops, but there we go. So I'm also using generate in the tests as well. So it's a really kind of handy tool to use. And these are things that are also used when you're doing, like if you're running spec test check, it also uses the generators to do that for you. There we go. That's what I was looking for. So this is in the specification banking namespace. So we got all our specifications, and here they're generating samples. So we can generate a sample of customer data, customer details, and so it's generating a whole range of different kind of values, just randomly done. So it's kind of going to create a new value each time. So it's a great way to actually test a wide scope of values within the specifications. And the same thing with account holders as well. So the only difference between customer details and account holders is that account holders has a UUID, which is what I initially designed for that kind of spec. And so if we just want a specific one rather than using sample, we can just use generate, and we get there we get our value. Oops, there we go. Boop. And so these are qualified. So it's got the Practicalli .specification banking as a qualification on the map. So that means that every keyword inside the map is actually not just first name. It's actually Practicalli specifications banking / first name. So these are because we put this hash and the keyword namespace on the front of the map. then that's basically qualifying all the keys inside that map, and so they're all getting that specification, that namespace attached to them. And that's the preferred approach to actually use that, but it also does mean that you have to think a little bit more about what namespaces you're going to use, as we'll see when we try and use this against the database. And so the specifications banking, I've also put the mock data, customer data details in there as well. So I was using these really in the database access. I was using these to kind of generate that. It saves me adding all the spec requires into a different namespace if I want to try that. I can just require the specification banking, and that makes it a bit simpler. Okay. So yes, and then using this spec generating approach, we can basically just call the mock data. So we can create a record, which is the kind of generic function we've created. We're passing in a DB specification, passing in the table name, and then we're passing in a generated account holder. So we're actually just basically putting in the full kind of finished set of values we want to add to that database. Now that doesn't quite work because we mentioned that we have a database schema that has snake case words, and we actually get a specification that's got camelcase. So we get this kind of error. So make it a little bit bigger. Oops. What are we doing? Oops, apologies. So we get this disparity between. Why is that not? Oh, that's why. We get this disparity between the kebabcase and the snake case, and so we get errors here. So it's you can see in the error, hopefully, that it's actually first name is first dash name, last name dash name, and so on. And so there's a kind of a mismatch. We're trying to update columns in the database that aren't the actual names of the columns, because these are names we use in the spec, and it's not. It's giving us an error because it can't find the right column names. So it's actually, you can see in the error what it's doing is it's just looking for first. So actually the dash in the name is actually used as a separator. So it's kind of finding first, and then it sees a dash and thinks, okay, that's the end of the name. So that's not good. And it seems like most relational databases have this issue as well. So we can't really use kebabcase. So we could, how do we do it? We could convert it ourselves. We could rewrite the spec generators, which would be a bit extreme, a bit excessive, just for databases. And this is just for relational databases as well. So other databases might be perfectly happy with so kebabcase names as well. But most relational databases seem to have this issue. And so what we can do is, luckily, we could use something like this library called camel snake kebab, which is a really nice library, very simple, and basically it just does what it says on the on the project name. It'll convert between camelcase, snake case, and kebab case, and so you can just use the library functions. So this is to camelcase, so we're just using the little arrow here as a naming convention. It's saying basically whatever argument we give it, we're going to pass it, we're going to convert it to camelcase. So it doesn't matter what kind of argument we're going to get, we're always going to get the camelcase version of that. So it's taking, here we're taking a symbol that's in kebab case, and it's returning camelcase. So it's a really nice handy little function, handy little library. It's so useful, in fact, that the very nice developers of Next JDBC have included this so that if you put camel snake kebabcase on as a dependency in your project, then you can get Next JDBC to do that for you. So rather than having to create your own, or rather than having to include your own converters, you can get Next JDBC to do that for you as well. We switch back to the code. Oops. And if we go to database access, so I didn't need to include anything in the namespaces, but if I look at the deps here, so I've added camel snake kebab. There we go. To my dependencies, and just restarted the REPL. And so that makes that available to Next JDBC. And yeah, and it gives us these two hash maps. And so we've got Next JDBC snake kebab options, and the same thing but for unqualified values, so keywords without kind of the namespace attached to them. And so actually the simple way to fix the using specs with the database table is to just include these in the function calls that we're using, the Next JDBC function calls we're using to basically create a new record. So it's just a matter of, so we can take our function, so we can take our create record, which is just a wrapper around JDBC SQL insert. And rather than actually just pass the map options in, what I've done is just added it to the end. So this is really a hash map of values, of option values. And if we go and jump to the code, which is in, here. So what I've done is, where I put it? There it is, create record. So we just go in and add this JDBC snake options. And if we evaluate that, I think, there we go. So this is just the evaluation of this name, this snake kebab options, and you can see it's resolving to a map, a hash map that basically defines which functions to use for converting between kebabcase and camelcase. So if we want to convert, so we can convert the qualifier and the label and the builder and the column names. So here, so you can, so we're wanting to convert the column names automatically, and so when it sees a column name, we've got this key which is a column name function. So that tells basically Next JDBC query builder to use this camel snake kebab.core snake case function to convert the column names that are in kebabcase into snake case. So that's nice and simple. So all we need to do is just add that to our JDBC insert as a sort of like a final option, wherever we're actually passing in kind of spec-based data or Clojure kebab case data. Then we just add this JDBC snake kebab options. The JDBC is just the alias I'm using for Next JDBC. So I probably need to add that for create tables as well. Oh no, not create tables. Yeah, if I was going to pass in the table data as a map, then I need that. But we're just using an SQL statement for that for the moment. And then, so I've added it for create records. Don't need it for read records because we're not passing in any Clojure data into that. We just the moment we're passing in an SQL query, and we're doing that for update records as well. The record data we're passing to update a record. We can pass that as Clojure kebabcase, and this option at the end will convert that to camelcase for us. Boom, boom, boom. So we got this a little bit of business logic just to say, well, we want a new account holder, and we're going to pass in the customer details. So that customer details can be our generated Clojure spec data. And then we're going to call create record with the dev database and the particular table and the customer details as the map that's generated from the spec. And so we can then call kind of new account holder. And if I got it right, what we got? Oh, we got file locked. Yes. Oops. I still got the database running. There we go. Ooh. Disconnect. And there we've got a, oh, it's working, cool. We've got a new account created, and we're using a spec. So this is just a kind of a hard-coded version of what the spec would be, and we're passing that in, and we get the results. And then if I do the same thing with new account holder, we want to pass it in the generated data. So we want to did I include that? Oh yes, I did. Yes. So we can include Practicalli specific banking. There we go. Mock. And we want to pass in customer details. So that's the same as passing this map, this namespace qualified map. So hopefully that should work the same. Yay! And it's returning, the value it's returning is the just the generated value. So it's not returning the whole row of values that are created in the database. It's just returning at the moment it's the value that's automatically generated. In this case, the UUID that's generated automatically. There we go. Oh no! Oh, wrong one. There we go. So we got account holder's ID, which is a UUID of a very long number, but we can see that it's actually not. It's returned a qualified map, which is good. Unfortunately, the qualification is not the same as our original namespace that we used, which actually looks like a nicer name to actually use for that. And so I'm starting to think, when I saw this, I started to, even before I was kind of getting error issues, that actually I should refactor the Practicalli specification banking namespaces. So it's this kind of namespace is typically how I'd organize the functions into logical groups in my application. So that's why I kind of chose that name initially. But this kind of this namespace is more relevant to what the actual purpose of this particular value is. So I'm starting to think that a simpler namespace would be more useful, and so I'm going to try and think about the design of that to kind of get these, because I want to ideally align these so that the qualification I'm automatically getting back when I'm doing an insert into the database is the same as the same namespace I'm getting in my specifications, because that makes it really easy to actually test using the spec valid and spec conform tools that are already there. So where do we get to? Yes. Yep. Yeah, so we've got this disparity between the names, which if we use spec valid, then we can test to see whether it's a account holder ID. Unfortunately, we're kind of checking to see whether it's a Practicalli specifications banking one, and it's actually returning an account holders one. So from this just simple test, it kind of suggests I want something more like account holders rather than specifications banking, because this is much more specific to the value. So I'm going to look at the design of those and potentially change the kind of namespaces I'm using for the specs. I don't think I need to change the specs themselves. The overall design of the specs is just kind of the namespaces I'm using for those specifications. And because the specifications are can be kind of used globally throughout the application and even potentially through all of your applications, then I guess that the specification namespaces don't necessarily need to be the same as the namespace that they're actually in. So I can still organize the code as it would do, but actually just use more specific namespaces for all the spec I'm creating. So that's something I'm going to work on over the weekend, have a bit of hammock time to think about that. Because when I'm coming to test with unit tests, then that's fairly straightforward. I'm just adding the different spec libraries in here along with the normal Clojure test. Just adding spec for the specs, test to run the to instrument functional definitions, and they've got the specgen alpha to be able to generate functions from there. And then I can create something like that is the simple test and just check that it's returning a map, which is fine. That works okay, because when we call new account holder with this generated specification, it's going to return a map. But it could be returning like an empty map, it'll still be valid. So it's not that good a test, but it is testing that we can actually use a generated spec value with this in a unit test. If we switch back to the code for a second, and let's go to the test itself. So if we try and do spec valid here on the specification, then it is working. It's updating the values in the database. So this call to new account holder with the specification is working, and we are getting an account holder ID spec. We're just getting a different namespace to that as well. So when we run the tests, we get a failure. 1 out of 7 isn't bad. So this is where we get the failure. You can see we've got the account holders ID coming back. It's returning UUID, but yeah, it's not the same as Practicalli specification banking because it's a different namespace. Oh, googles. Oops. There we go. So I'm going to look at refactoring my spec names. And there's another issue when we want to actually run this. Even if we're using kind of map, then all our tests will run locally. But when we're running our tests in a continuous integration environment, then we get an issue where we haven't actually got a database, or we're starting from scratch. So the kind of environment is empty to start with. And so we'd need to create the database tables when we run the application. But when we're developing, then we might already have the tables there, so we don't want to kind of recreate the tables if they're already there. Luckily, there's a simple way to do that in the SQL. There's this if not exists. So I'm going to add those to each of the table schemas as well. And so that will help us. So I can put in some code around the tests to basically say that go and create the tables using the schema. And so we do like a little setup function for the tests, and then create these tables. And if they're already there, then it's not going to affect it. So I can run the tests both locally and in the CI environment without any issues there. We covered quite a lot there quite quickly. Hopefully that all made sense so far. I'm going to add that kind of content to the kind of H2 relational database stuff in here as well. Did I add anything extra in here? No, not yet. No. Oh yeah, and so there was one other change I kind of made. Let's see. So when I was thinking about how to create the records, so create our I actually want to be able to pass the customer data in. And one thing I've kind of skipped over is I've made a change to the database. So rather than passing in a generated UUID, so this is kind of basically passing in a account holder details, when actually what I'm getting from the request, the initial request, is just the customer details. So I don't actually have the account holder ID, which I could generate at some point, but I can also get the database to generate that for me. So if we switch to the we go back and switch back to a high level of the request handler. Request handler, nope, not the test. Request handler itself. And then we've got, oops, where is it? There we go. So when we come to our application, we can go we can create a form on the web page, which I'll need to do at some point, to register the account holder. So we'll get a form, and that form will basically collect all the data that will make up the same information as the spec for the customer details spec. So first name, last name, email, residential, and social security. I have simplified these in the code to just all be strings. So residential address is just a string now, rather than being a composite specification of address, country, postcode, etc., etc. So now it's just all self-contained as a simple string. That also makes it easier to do a test around as well. And the same for social security, it's just a string at the moment rather than a country specific one. So what we're doing in the account holder is we're so register account holder handler. We can just call this new account holder that we've been doing, and here I'm just passing in a spec or a hard-coded spec, and then this would go off and update the database. But you see, we're not actually including the UUID here. We could put in we could generate one and add it in and pass it along. But if we're just using the customer data, then it's a little bit tricky to kind of merge into a value into a spec. There is a specific spec merge function in the spec library. But if we pass in a spec in there, then this basically will update it and return it returns the value. So we'll get back the account handler ID, and so that helps us. We can use that value then to pull out information from the database about that particular customer, and obviously, then the customer can see their own setup using that value. So to make this work without generating our own UUID, we get the database to do that. And so I had a little Google about the best way to do that. So if we go back to account database access, there we go. And go up to the specifications for the schemas. So I've basically changed these to be, so the account holder is a UUID, and it's using this random UUID function, which is a function that's part of the database. And this seems to be, it's definitely there for H2. I'm going to check that that's available for Postgres as well. And just making sure that this value is non-null, I guess, so that whenever we create a new record inside the public account holders database, then this is going to automatically generate that account holder ID for us as a UUID. And generating it, I did have some problems with some other kind of older approaches. I got some issues with it not understanding the value that it created itself. So random UUID seems to be the more reliable approach to doing things. And I think I did the same kind of thing for other things as well. So you can use identity, which is what I was trying to use, but I was getting issues with identity and UUID. I think identity is, because identity is trying to create the next sequential number, whereas UUID is just going to generate a random UUID. So this is like what we were doing with the Java util UUID random UUID function. Whereas this is going to try and create a sequential UUID, and now I was getting all sorts of interesting errors around there as well. So if you're using identity, then that seems to be the modern way of using an auto-incremented value, so long as it's not a UUID, because at least H2 was getting very confused about that as well. And so there I've also done the same for the transaction ID as well. So I expect there to be a lot of transactions, so then I'm more comfortable using a UUID, so I don't put lots of transactions in there. Account numbers, there's going to be a limited number of accounts, so just using an integer is fine for now, or maybe a kind of a long. I need to check exactly to see how big that value can get. But this is the value that's going to be. This is the value account number will be shared on the website, and so sharing a UUID is a bit ugly for a user interface. whereas the account number is a nice simpler number that people are more comfortable using, and it's also something you might need to type in. It'd be the account number that you would find on your bank card, your credit card, so your bank card, debit card, and so you want a more human-friendly version. Then there's no way you're going to remember a UUID, and you certainly don't want to type a UUID value in from your credit card. That would be painful. But these seems to work, so I can just pass in for here I can just pass in the customer details, and it will automatically create the account holder ID, and then I'm just populating all the rest of it. And I've left the constraints as left the primary key as a constraint, so they can specifically specify the name of that constraint. Just help me with debugging. So that was putting in this random UUID is a change I've made for the schemas, and I'm also going to think about the names of these tables just to get some alignment between the spec namespaces and the names of the database tables. That'll make it easier to do a whole bunch of testing automatically for us. Anything else before I go? Any questions so far? So this has been mainly about kind of the challenges, so hopefully I'll have all those ironed out by next week. Let's see if there's anything else I've forgotten about. Yeah, no, I think that's good. Yep. And then in the request handlers, you see there's a lot of, so I'll tidy up the request handlers as well. There's a lot of things here, but essentially all we're going to be doing from the request handlers is we take the request, I'm going to extract the values that are in that represent the customer details, pass those to call the new account holder with those details, and then wrap this in just a page results that we're going to return. So we'll return like a account created or account holder successfully registered. This is your account number. This is your kind of unique ID, and that wants to be in some kind of nice template. So we need to create, rather than like hard coding the response in here, we're going to create a template, and that way that'll help us separate out our namespaces, so we can have a namespace design where this UI pages and templates is not part of the middleware. It's actually part of its own namespace, and that makes the handlers a lot simpler. All the code in here is a lot simpler to kind of read and follow. Okay, I think that's it for today. If you got any more comments, then feel free to reach out to me at the Practicalli channel on the Clojure in Slack, and if you don't have an account, you can sign up there as well. I also start to use Zulip more as well. So yeah, so if you go and Google for that, I'll put a link on the website for this as well. But there's a Clojure in Zulip, which is just like Slack, except it's a little bit nicer, it's a little bit more organized actually. And you've got streams, but you also got like topics within streams as well. So it's a lot easier to kind of navigate through threads of conversation. So it looks a little bit more complex at first, but it's actually a lot easier to find things once you've spent a few minutes just kind of getting used to a more organized approach than the the general banter that you get in Slack. And this also has the Slack archive as well. So if you want to go back and search for stuff, then this is a great tool to do that. So I think if you go to blog, yeah, in the Getting Help article in my practicalli.github.io blog, then yeah, there's some tips on using Zulip and some other useful websites as well. Yeah, so it's worth having a quick look at this Clojure and Zulip just to get an idea about how it all works. And if you want to go and search stuff, you can search the Slack archive, and then the topic is the channel that you want to have a look at from Slack. I should do Practicalli at some point, shouldn't I? There's also an app for Zulip as well. Boom, boop, boop, boop. Do a search. I think I've got that. There we go. Whoa, there we go. Oh, there's me. There we go. Yeah, so this is the archive. So if you've missed something on Slack, which only has about a week's worth, then oh, I might have to look at my own archive. Then it's very easy to go and have a look at the history of Slack in Zulip. Alrighty, I'm going to leave it there, and hopefully everybody has had a good week, and hopefully looking forward to an even better weekend. So thank you very much for joining me, and see you next time. Thank you very much. Goodbye.